Welcome to Science, to Sleep By, and another journey through the quiet, endless beauty of the universe. Tonight, we'll take a slow and thoughtful look at something that surrounds us all, yet remains hidden to our everyday eyes: the Milky Way galaxy. The grand spiral of stars, dust, and mysteries that we call home. Here in the United States, we're fortunate to have vast open skies, from the deserts of Arizona to the plains of Kansas, from the mountains of Colorado to the quiet lakes of Minnesota. On clear nights, far away from city lights, the Milky Way stretches across the heavens like a river of silver. It's a sight that reminds us how small we are, yet also how connected we are to something unimaginably large. So tonight, as you rest and let your mind drift, let's explore the question: just how big is our galaxy? Together, we'll gently travel through space and time, with calm reflection and wonder. In this episode of Science to Sleep By, when we ask the question, how big is our galaxy, we are immediately stepping into a realm where human imagination begins to strain against its limits. The Milky Way, our home galaxy, is a colossal spiral of stars, gas, dust, and dark matter, stretching across an estimated 100,000 light-years. That figure alone might sound impressive, but when you pause to reflect on what it actually means, you begin to realize that this is not just a number, it is a measure of vastness beyond anything we can easily picture in our daily lives. A light-year is the distance that light, the fastest thing in the universe, can travel in a single year. Light races along at about 186,000 miles per second. In just 1 second, it can circle the Earth nearly 8 times. Multiply that by every second of every day, for an entire year, and you arrive at the staggering distance of almost 6 trillion miles. Now imagine stringing together 100,000 of those light years, one after another, and you begin to sense the immensity of our galaxy. To give it a more familiar perspective, consider this: if you could board a spaceship capable of traveling at the speed of light a feet far beyond our technology, you would still need 100,000 years just to cross from one edge of the Milky Way to the other. And that is only if you took a straight path across the galactic disk. If you tried to meander along the spiral arms, weaving through clusters of stars, glowing nebulae, and the dark lanes of dust, your journey would stretch even longer. Compared to this, the span of a human lifetime feels like the blink of an eye. 100 years to us is a long story of generations, of lives lived and remembered, but in the scale of the Milky Way, 100 years is not even a fleeting whisper. Think for a moment about how small our daily distances are. Driving across the United States, coast to coast, might take several days. Flying from New York to Los Angeles takes about 6 hours. These distances feel significant when you plan a trip, or imagine the miles ticking by. Yet these journeys, measured in thousands of miles, shrink into insignificance when compared with a light year, let alone 100,000 of them. The sheer scale of the Milky Way humbles every earthly measure, reminding us that our familiar world is only a tiny island in a vast ocean. The immensity of the galaxy also reflects the immense number of stars it contains. Scientists estimate that the Milky Way holds between 200 and 400 billion stars, scattered across its disk and bulging center. When you step outside on a clear night and look up, the stars you see are just a fraction of what lies beyond. Most of them are not even visible without a telescope, yet they are all part of this single galaxy or shared home in the cosmos. Imagine each star as a glowing point of light, each one possibly with its own planets, its own moons, its own possibilities of life. Multiplying this across hundreds of billions of stars, the galaxy becomes not just vast in size, but vast in possibility. When astronomers try to capture the size of the Milky Way, they often use comparisons. If our solar system, stretching out past Pluto and the Kuiper Belt, were shrunk down to the size of a coin, then the Milky Way would be the size of the continental United States. Within that enormous expanse, our sun would be just one coin-sized dot among countless others. The analogy helps, but even then, it is difficult to truly picture. Our minds are wired to think in terms of things we can touch and see: cities, countries, planets, even stars. The leap to imagining something that spans 100,000 light years is not natural, but it is precisely this leap that makes contemplating the galaxy so awe-inspiring. The immensity of the Milky Way also carries with it a sense of history. Light takes time to travel across space, which means when we look at distant stars, we are seeing them not as they are now, but as they were when their light first began its journey to us. Some of the stars in our sky are hundreds, even thousands of light years away. Their light left them before the rise and fall of human civilizations, before written history, before even the first humans walked the earth. When you think of the galaxy as 100,000 light years across, you realize that light from one side has not even had time to reach the other side since the dawn of human existence. The galaxy is not only vast in space, but it is vast in time. Astronomers often speak of the Milky Way as if it were a city, and in many ways it is. The Galactic Core is like the bustling downtown center, crowded with stars packed tightly together, while the spiral arms spread outward like winding avenues lined with neighborhoods of stars and gas clouds. Our solar system resides in one of those quieter suburbs, far from the central hub, on a minor arm called the Orion Arm. From our location, we can only glimpse pieces of the galaxy, the arc of the Milky Way seen on a dark night. The smudge of stars stretched across the sky, but the true size of the city we live in is almost impossible to comprehend. And yet, even as we try to grasp its immensity, the Milky Way is not alone. It is just one galaxy among perhaps 2 trillion in the observable universe. Each of those galaxies carries its own immensity, its own billions of stars and possible worlds. But when you return your focus to the Milky Way, to our home, you begin to feel a strange comfort. Yes, it is unimaginably large. Yes, it is humbling beyond words. But it is ours. It is where all of human history has unfolded, where every poem was written, every song was sung, every dream was dreamed. It is the cosmic neighborhood we know best, the backdrop to our story in the universe. The immensity of the Milky Way is a reminder of both our smallness and our belonging. We may be tiny compared to its scale, but we are part of it nonetheless. Every atom in our bodies was forged in the hearts of ancient stars. Stars that once lived and died within this galaxy. We carry its history within us, and we look out into its immensity with eyes that can wonder, with minds that can imagine, with hearts that can be humbled and calm. Thinking about the size of the Milky Way can make you feel small, but it can also make you feel deeply connected to something unimaginably vast and enduring. When we look up into the night sky, we see only a sprinkle of stars, perhaps a few hundred if the skies are truly dark and free of city lights. These stars appear scattered, delicate, and even intimate, as though they were hand-placed for us to admire. Yet what we see is only the faintest suggestion of what lies beyond. The Milky Way is a galaxy so abundant with stars that our eyes cannot begin to take them all in. Astronomers estimate that the Milky Way contains somewhere between 200 billion and 400 billion stars, though the exact number remains uncertain because the galaxy is so immense and the stars so numerous. To even attempt to count them all would be like trying to count every grain of sand along the shores of every beach on Earth. And even then, the comparison would not fully capture the scale. Think for a moment about the number 1 billion. It is a word we use often, but it is rarely something we pause to grasp. A billion seconds, for example, is about 31.5 years. A billion heartbeats might spend the lifetime of a large animal. Now multiply that by hundreds, 200, 300, even 400, and you begin to get a sense of the number of stars glowing within the Milky Way. Each one of those stars is a sun, releasing light and energy, burning across millions or billions of years. Some are small and faint, red dwarfs that shine with only a fraction of the brightness of our sun. Others are giants, massive blue-white stars radiating so intensely that they outshine thousands of suns combined. Still others are in pairs or groups, orbiting together in stellar dances that have lasted for eons. All of these, billions upon billions, make up the starry ocean of our galaxy. Our own sun is just one of these countless stars. an ordinary yellow dwarf star that happens to have planets orbiting it, one of which is Earth. It may feel natural to imagine that our sun is somehow special, but in truth, it is remarkably typical. Stars like it are scattered throughout the galaxy in almost unimaginable abundance. And if our sun, ordinary as it is, can host a system of planets with a world like Earth, then it raises the question, how many other stars might also host their own families of planets? In recent years, astronomers have discovered that planets are not rare, but rather the norm. Almost every star is thought to have planets orbiting around it, and some may have entire systems of them, just as our sun does. These discoveries have transformed our understanding of the galaxy. What once seemed extraordinary, the idea of other worlds, has now become expected. Among the hundreds of billions of stars in the Milky Way, there may be hundreds of billions of planets as well, some small and rocky like Earth, others giant and gaseous like Jupiter, others frozen and distant like Neptune. Many of these planets remain hidden to us, too faint to detect with current technology, but their presence is implied by the overwhelming patterns we have already seen. The sheer possibility is staggering. Among billions of stars and billions of planets, how many worlds might exist that are capable of supporting life? How many might have oceans, rivers, mountains, and skies? How many might have organisms breathing, moving, growing under alien suns? The truth is that we do not know, and perhaps we may not know for a long time. But the immensity of numbers alone makes it seem unlikely that Earth is the only world where life has taken hold. Even if life is rare, extraordinarily rare when multiplied by the nearly countless opportunities across the Milky Way, it becomes plausible, even probable, that somewhere among the stars there are other worlds that have their own stories unfolding. Consider, too, the age of these stars. Some of them were born billions of years before the Sun, long before Earth ever formed. Entire histories of star systems may have come and gone within the galaxy before our planet was even a thought in the cosmic timeline. Other stars are still young, newly ignited, with their planets still forming from disks of dust and gas. The Milky Way is not a static collection of stars frozen in place. It is alive with birth and death. Stars form in vast nebulae, glowing clouds of gas that serve as nurseries. They live their lives, some short and brilliant, others long and steady. And when they die, they return their material back into the galaxy, enriching it with elements that will form new stars, new planets, and perhaps new life. This cycle of creation and renewal adds yet another layer to the idea of countless worlds. Our own existence depends on the lives and deaths of stars that came before us. The iron in our blood, the calcium in our bones, the oxygen we breathe, all of it was forged in the hearts of ancient stars that lived and exploded long ago. In this way, every human being carries within them the story of the galaxy, the legacy of billions of stars. The same is true for every creature, every tree, every grain of sand on Earth. We are, in the truest sense, children of the stars, and part of the ongoing story of the Milky Way. When you gaze at the Milky Way on a clear night, stretching across the sky like a shimmering river, you are seeing only the surface of this abundance. Most of the stars that make up its light are too faint to resolve individually. They blend together into that glowing band, a reminder that the galaxy is crowded with suns beyond counting. Each of those suns is a potential beacon of possibility, a reminder that our home is not a solitary dot of light in an empty void, but a member of a vast, luminous community. Astronomers often speak of exoplanet planets orbiting other stars as the next great frontier of discovery. Already, telescopes have confirmed thousands of them, and each one adds to the sense that the galaxy is filled with diversity and wonder. Some orbit close to their stars, so near that their surfaces are scorched and molten. Others orbit far away, locked in deep cold. Some are gas giants many times the size of Jupiter, while others are rocky and small, like our own Earth. Among them, scientists search for the so-called Goldilocks worlds, planets that are not too hot, not too cold, but just right for liquid water to exist on their surfaces. These are the planets where life as we know it could have a chance to thrive. And with billions of stars to search, the hunt for such worlds is only just beginning. The knowledge that there are billions of stars and countless worlds within our galaxy can shift the way we see ourselves. On the one hand, it can make us feel small, a single world among so many, a tiny speck in a sea of possibilities. On the other hand, it can fill us with awe and wonder. To live in a galaxy so abundant, so full of stars and planets, is to live in a place rich with mystery and beauty. It is to be part of something vast and ongoing, a cosmic story that stretches across light years and millennia. When we imagine the Milky Way, it helps to think of it not as a random scattering of stars, but as a grand, spiraling design, a celestial pinwheel turning slowly in the darkness of space. Spiral galaxies, like the Milky Way, are some of the most beautiful and recognizable structures in the universe. Their arms unfurl outward from a dense central core, sweeping in graceful arcs, filled with clusters of stars, luminous clouds of gas, and lanes of interstellar dust. Our galaxy is one of these spirals, and within its vast structure, our solar system occupies a very particular address. We live on the Orion Arm, sometimes called the Orion Spur, a minor branch of one of the galaxy's larger spiral arms. Our Sun, with its orbiting planets and moons, is nestled in this quiet region, far from the galactic core, and far from the outermost edges. About 2/3 of the way out from the center dot, it is easy to forget that our position in the galaxy matters. Just as a person's address on Earth shapes their view of the world, our cosmic address influences what we see, what we experience, and even the conditions that made life possible on Earth. The Orion Arm is not one of the Milky Way's grander features. It is not as prominent as the Sagittarius Arm or the Perseus Arm, both of which span vast reaches of stars and glow with the activity of star formation. Instead, the Orion Arm is more like a side street branching between two larger avenues. Yet this humble location has proven to be a remarkable vantage point. From here, we can look inward toward the dense, bright center of the galaxy, and outward toward the quieter edges, giving us a perspective of both. The Orion Arm is about 3,500 light-years across and 10,000 light-years in length. Within this expanse lie many familiar celestial sights. The bright belt of Orion, the dazzling Pleiades cluster, and the Great Orion Nebula itself are all found in this region. These are the kinds of objects we admire with telescopes, the ones that have inspired myths, stories, and wonder for centuries. They are not just pretty decorations in our sky, they are the landmarks of our neighborhood in the Milky Way. Our Sun is one star among many scattered through this arm, quietly orbiting the galactic center at a speed of about 514,000 miles per hour, completing a single orbit roughly every 225 to 250 million years. That means the last time our solar system was in this same place in its orbit, dinosaurs were roaming the Earth. We are passengers on a star that is constantly moving, tracing its slow path along with billions of others, together forming the spiraling pattern of the galaxy. Our location within a minor arm also comes with a kind of safety. Closer to the galactic center, stars are packed much more tightly together. There, the density of stars creates chaotic environments, with higher chances of dangerous cosmic events, such as supernova explosions or the gravitational disturbances of passing stars. Out on the Orion Arm, the stellar density is lower. Our Sun is comfortably distant from its nearest stellar neighbors, with the closest, Proxima Centauri, about 4.24 light-years away. This separation has given Earth a relatively calm and stable environment in which life could emerge and evolve. If we lived closer to the core, the conditions might have been far harsher, making it much more difficult for a planet like ours to sustain the fragile balance necessary for life. Being in the Orion Arm also affects the way we see the galaxy itself. When we look up at the night sky and notice the hazy river of light we call the Milky Way, what we are seeing is the combined glow of millions of distant stars along the galactic disk. Because we are inside this disk, our view is like standing in the middle of a forest. Wherever you look, you see trees stretching into the distance. Similarly, No matter which direction we look along the plane of the Milky Way, we see stars piled one upon another, their light blending together. From Earth, this gives us that iconic streak across the sky. If we lived in another galaxy looking back at the Milky Way, we might see its full spiral shape. But from our perspective, embedded within one of its arms, we see only slices, hints, and glimpses. This inside perspective is both a limitation and a gift. We cannot step outside our galaxy to take a direct picture of it, at least not with current technology, but we can infer its shape and structure by studying the stars around us. Astronomers map the Milky Way much like early explorers once mapped continents, by carefully observing landmarks and piecing together the broader shape from partial views. Over time, we have come to understand that the Orion Arm, though small, is richly populated with some of the most recognizable and studied objects in our night sky. It has given us both the conditions for life and the beauty of cosmic sights that have stirred human imagination for millennia. Our place in the spiral arms also reminds us that we are part of a dynamic and ever-changing galaxy. The Milky Way is not frozen. Its spiral arms are patterns of density waves, where stars and gas are temporarily crowded together before drifting onward. As our solar system orbits the galactic center, it will eventually move into different regions, passing through spiral arms, crossing denser clusters, and moving outward again. This long, slow journey means that the environment of our solar system changes across the span of millions of years. Some scientists even suggest that Earth's history, including periods of mass extinction and bursts of life, may be influenced by our solar system's movement through the galaxy. As we pass through regions with higher chances of cosmic radiation or encounters with interstellar clouds, on a more personal level, our place in the Orion Arm offers us something profoundly comforting. It is a reminder that we are not isolated. Our sun, our planets, and our world are part of a larger family, a neighborhood of stars bound together by gravity, moving in harmony through the galaxy. When we look at the stars in the night sky, we are not just seeing distant lights, we are seeing our neighbors, the members of our galactic community. Some shine bright, some dimmer, some are closer, others farther, but together they form the backdrop to our existence. The Orion Arm is, in many ways, an unassuming place. It is not the most spectacular or the most crowded. Yet from here, we can look both inward and outward, gaining a perspective that connects us to the galaxy as a whole. We are close enough to see the brilliance of the central regions, yet far enough away to enjoy the calm stability of the outskirts. Our place in the spiral arms is both humble and extraordinary, ordinary and miraculous. It situates us within the Milky Way, not as outsiders, but as participants in its story, carried along by the same forces that guide billions of stars. At the very heart of the Milky Way lies a place so dense, so mysterious, and so powerful that it continues to captivate astronomers and stir the imagination of anyone who thinks about it. This region is known as the Galactic Core, the central hub of our spiral galaxy, a place where stars crowd together in numbers unimaginable to us here in the relatively quiet outskirts. If the galaxy is a great city of stars, then the core is its downtown, a glowing, bustling center where energy, gravity, and light converge. It is both dazzling and dangerous, a region that has shaped the Milky Way's story for billions of years. The Galactic Core is located about 26,000 light-years away from Earth, in the direction of the constellation Sagittarius. We cannot see it directly with our eyes because thick clouds of interstellar dust obscure our view, blocking visible light from reaching us. Yet astronomers have learned to peer into this hidden realm using other forms of light: radio waves, infrared, and X-rays that can slip through the dust. What they have found is astonishing. At the very center of the galaxy lies a supermassive black hole, an object known as Sagittarius A. This black hole is about 4 million times the mass of our Sun, compressed into a region so compact that not even light can escape its pull. It sits silently in the heart of the Milky Way, an invisible anchor around which the entire galaxy revolves. The presence of Sagittarius A was not always known. For much of the 20th century, scientists speculated about what might lie at the galactic center. Observations of stars near the core showed them moving at extraordinary speeds, whipping around an unseen mass with velocities that could not be explained by ordinary stars alone. The only explanation was that something unimaginably massive must be there, something compact enough to fit within a relatively small space. Over time, the evidence built, and in the early 2000s, astronomers were finally able to track individual stars as they orbited close to the invisible center. These stars traced paths that revealed the black hole's presence with stunning clarity, confirming that a supermassive black hole resides in the heart of our galaxy, despite its immense gravity. Sagittarius A is not a monster that devours everything in sight. For the most part, it sits quietly, with material only occasionally falling toward it. When gas or stars stray too close, the black hole's gravity pulls them in, heating the material to incredible temperatures as it spirals inward. In those moments, Sagittarius A flares brightly in X-rays and radio waves, shining like a cosmic beacon. These flares remind us that even in its quiet state, the galactic core holds a reservoir of unimaginable power. Surrounding the black hole is a dense region filled with stars. Unlike our part of the galaxy, where stars are relatively spread out, the stars near the core are packed together, some within just a fraction of a light year from one another. Imagine standing on a planet in that region. The night sky would blaze with hundreds or even thousands of stars, each one brighter than the brightest stars we see here on Earth. The darkness of night, as we know it, would be replaced by an eternal glow, a celestial crowd of suns burning together. It would be a sight both beautiful and overwhelming, a reminder of how different the universe can appear depending on where you stand within it. The galactic core is not only dense with stars, but also rich in gas and dust. Vast molecular clouds swirl in this region, serving as nurseries for new stars. Star formation is intense here, fueled by the abundance of material and the gravitational forces that compress it. At the same time, the core is a place of destruction, where massive stars live short, brilliant lives before exploding as supernova. These explosions release torrents of energy, enriching the surrounding space with heavy elements and adding to the cycle of creation and renewal that defines the galaxy. It is a region of extremes, light and darkness, birth and death, silence and violence, all intertwined in a cosmic dance. For astronomers, studying the galactic core is like peeling back the layers of a mystery that has been unfolding for billions of years. Every new observation reveals another piece of the puzzle. Infrared telescopes allow us to see the stars that orbit close to the black hole, their paths like signatures written in light. Radio telescopes pick up the faint hum of gas clouds swirling through the center. X-ray telescopes catch the brief flares when matter falls into the black hole's grasp. Together, these tools give us a portrait of a place we cannot see directly, a place hidden yet central to our existence. The galactic core also shapes the overall structure of the Milky Way. The spiral arms, including the Orion arm where we live, extend outward from this central hub. Gravity binds everything together, the stars, the gas, the dust, all circling around the mass concentrated in the core. Without this anchor, the galaxy would not hold its shape. In many ways, Sagittarius A is the keystone of the Milky Way, the unseen foundation upon which everything else rests. Thinking about the galactic core invites us to reflect on scale and perspective. We are so far away from it that light takes 26,000 years to reach us, and yet we are connected to it by the pull of gravity. It is a reminder that in the vastness of the galaxy, we are part of a larger system, bound together by forces we cannot feel, but that guide the motion of every star. Our lives, short and fragile, unfold in the quiet outskirts, while at the heart of our galaxy, a black hole millions of times the mass of our sun, silently exerts its influence. The contrast is humbling, but also deeply unifying. The galactic core is not just a scientific curiosity, it is also a source of wonder and inspiration. For centuries, humans have looked toward the constellation Sagittarius, noticing the dense clustering of stars and sensing that something important lies there. Ancient cultures wove myths and stories around that region of the sky, filling the unknown with meaning. Today, our stories are told in the language of science, but the sense of awe remains the same. To imagine the center of the galaxy is to imagine a place where light and gravity collide, where stars whirl in dizzying orbits, and where the fabric of space itself bends under the weight of mass beyond comprehension, even in the quiet of night. When we look at the Milky Way stretching across the heavens, the galactic core is present in that glow. Though dust hides it from our eyes, we know it is there, the beating heart of the galaxy, sustaining and shaping the spiral arms that sweep outward. We may never see it directly with human eyes, but our minds can reach for it, our imaginations can travel there, and our hearts can be stirred by the knowledge that such a place exists at the center of the cosmic city we call home. When we think about the Milky Way, it is tempting to imagine it as a flat disk of stars spread evenly across space, like a plate of light floating in the dark. But the true structure of our galaxy is far more complex, layered, and intricate than such a simple picture allows. The Milky Way is a vast and dynamic system made up of different components that together form a harmonious, though not always symmetrical, whole. Understanding its structure is like studying the anatomy of a living organism. Each part serves a role. Each part contributes to the galaxy's overall shape and behavior, and each part tells us something about its history. At the most obvious level, the Milky Way is a barred spiral galaxy. This means that its stars are not just arranged in circular symmetry, but rather, they form sweeping spiral arms that extend outward from a central bar-shaped region of stars. Imagine a pinwheel with a bright hub in the middle, its blades made of glowing stars, dust, lanes, and nebulae curving gracefully outward. That is the form our galaxy takes. Though we can only piece this image together indirectly. Because we live inside it, we cannot step outside and see the Milky Way from a distance, the way we see the Andromeda Galaxy or other spirals in the night sky. Instead, astronomers use careful observations of star positions, gas clouds, and radio signals to reconstruct the grand architecture of our galactic home. At the center lies the galactic bulge, a thick, rounded concentration of stars surrounding the supermassive black hole, Sagittarius A. This bulge is not a smooth sphere, but rather an elongated, bar-shaped structure, made of old, reddish stars that formed billions of years ago. The stars here are crowded closely together, much more densely packed than in our neighborhood of the galaxy. Surrounding this bulge is the galactic bar, which stretches across the core and funnels gas toward the center, fueling star formation and feeding the black hole itself. This bar is a defining feature of our galaxy, shaping the flow of matter and the arrangement of the spiral arms that extend from its ends. From the bar, the spiral arms unfurl like ribbons curling outward. The Milky Way has several major arms: the Perseus arm, the Sagittarius arm, the Scutum Centaurus arm, and several smaller ones, including the Orion arm, where our solar system resides. These arms are not solid objects, but rather regions of higher density, like traffic jams of stars and gas that slowly move through the galactic disk. Stars are born within these arms as clouds of gas are compressed by the density waves, igniting into new suns that light up the arms with their brilliance. Some of these newborn stars are massive and short-lived, burning intensely before exploding as supernova, while others are small and faint, destined to shine steadily for billions of years. Between the arms lie less dense regions, where stars are fewer and the gas is more dispersed. Yet even here, the galaxy is far from empty. There are still stars scattered throughout, still nebulae drifting silently, still dark matter weaving its unseen web. The spiral arms give the galaxy its structure, but they are part of a larger disk that spans about 100,000 light-years across and about 1,000 light-years thick. This disk is where most of the galaxy's stars, gas, and dust reside, arranged in a thin, glowing plane that defines the shape of the Milky Way. From Earth, when we see the band of the Milky Way stretching across the sky, we are looking edge-on into this disk, seeing the combined light of millions of stars layered together in the plane of the galaxy. Above and below the disk lies another component of the galaxy, the halo. The halo is a vast, roughly spherical region that surrounds the Milky Way, extending far beyond the visible stars. It contains ancient, globular clusters, dense balls of stars that are among the oldest in the galaxy. These clusters orbit the center of the Milky Way. They're stars as old as 12 or 13 billion years, relics from the early days of the galaxy's formation. The halo also contains dark matter, the invisible substance that makes up most of the galaxy's mass. Though we cannot see dark matter directly, we know it is there because its gravity holds the galaxy together. Without it, the stars at the outer edges would not orbit at the speeds we observe. They would fly apart into space. Dark matter forms a kind of invisible skeleton, giving the Milky Way its stability and shape, even though we cannot touch it or see it. The Milky Way structure is not perfectly flat or rigid. The disk itself is warped, bending upward on one side and downward on the other, like a vinyl record that has been slightly bent. Astronomers believe this warp is caused by gravitational interactions with nearby satellite galaxies, such as the Large and Small Magellanic Clouds, which tug on the Milky Way and distort its shape. Over time, these interactions ripple through the galaxy, shaping its structure in subtle but significant ways. This reminds us that the Milky Way is not an isolated object, but part of a larger cosmic community. Its form influenced by its neighbors and its history of collisions and mergers. Another important aspect of the Milky Way structure is its layered populations of stars. The stars in the thin disk, where our sun resides, tend to be younger and richer in heavy elements, the products of earlier generations of stars. The thick disk, a broader and older component, contains stars with fewer heavy elements, relics from a time when the galaxy was still young and less enriched. This layering tells the story of the Milky Way's evolution, of how it grew and changed over billions of years, building up through mergers with smaller galaxies and through the slow, steady birth of new stars. The Milky Way also has satellite galaxies of its own, smaller companions that orbit it, much like the Moon orbits Earth. Among these are the Large Magellanic Cloud and the Small Magellanic Cloud, visible in the southern hemisphere as faint smudges of light. These galaxies are gravitationally bound to the Milky Way, slowly interacting with it, exchanging streams of gas and stars. Over time, some of these satellites may merge with the Milky Way, adding their material to its structure. In fact, the Milky Way has already consumed many smaller galaxies throughout its history, their remnants now woven into the halo and the disk. The stars of these cannibalized galaxies orbit quietly among the rest, their origins hidden except to the careful studies of astronomers who trace their chemical signatures and motions. When we step back and consider all these layers, the bulge, the bar, the spiral arms, the disk, the halo, the dark matter, we see that the Milky Way is not a simple structure, but a rich and dynamic system. It is both orderly and chaotic, both graceful and turbulent. Its spiral arms may look serene in illustrations, but within them, stars are born in violent bursts, explode in fiery deaths, and scatter their elements into space. Its halo may seem invisible, but it is filled with ancient clusters that have orbited the galaxy since its earliest days. Its dark matter may be unseen, but it silently governs the movement of everything we can see. For us, living in one small part of this structure, the Milky Way can feel both vast and intimate. Vast, because its size and complexity stretch beyond our comprehension. Intimate, because every part of it is connected to us. The iron in our blood came from stars that once exploded in the spiral arms. The orbit of our sun is shaped by the pull of the galactic bar and the mass of the dark matter halo. The constellations we see in the night sky are our local view of the galactic disk. We are woven into the fabric of this structure, participants in its story. No matter how small our role may seem, when we begin to talk about the true scale of the Milky Way, words and numbers quickly lose their ability to convey meaning. Human experience is tied to distances. We can walk, drive, or fly. We measure our world in miles, in hours of travel, in the time it takes to cross a continent by airplane or to orbit the Earth in a spacecraft. Yet, when we turn our gaze to the galaxy, these familiar units collapse under the immensity of the scales involved. To make sense of these distances, astronomers use the light year, the distance light travels in a single year, moving at a staggering speed of nearly 186,000 miles per second. Even with this measure, the numbers we encounter stretch beyond anything the human mind can hold. In full, our galaxy is about 100,000 light-years across. That means, if you could ride a beam of light, if you could travel at the fastest speed the universe allows, it would still take 100,000 years to cross from one edge of the Milky Way to the other. Think about that for a moment. All of human history, from the first cave paintings to the present, spans only a few tens of thousands of years. Entire civilizations have risen and fallen in far less time than it would take for light to travel from one side of the galaxy to the other. The sheer immensity of this distance is beyond any journey we can truly imagine, and yet, it is the space we call home. Even within the galaxy, the distances between stars are vast. Our Sun's nearest stellar neighbor, Proxima Centauri, lies more than 4 light-years away. That may sound small compared to 100,000 light-years, but in terms of human travel, it is unfathomable. The fastest spacecraft we have ever built would take tens of thousands of years to reach that single nearby star. In other words, even the stars in our immediate neighborhood are separated by gulfs of space so wide that they dwarf all of human achievement in travel and exploration. When we look at the galaxy from our vantage point, we see its glowing band of stars stretched across the night sky. But what appears as a continuous stream of light is really the combined glow of millions of stars, so distant that their individual brilliance merges into a misty band. Each pinpoint of light is a sun, many with their own planets, separated from one another by distances so vast that, for most of history, humans assumed the stars were fixed in a dome above us. Only with careful observation and the development of science did we begin to understand that they are scattered across three-dimensional space, each separated from the next by incomprehensible expanses. Astronomers often try to make these distances relatable by using scaled models. Imagine shrinking the Milky Way so that the entire galaxy fits into the size of the United States. In such a model, our solar system would be no bigger than the width of a dime. The nearest star to the Sun would still be several feet away, and the galaxy itself, spread across the continent, would contain billions upon billions of stars. Even this analogy, though, can only go so far. Our minds are not built to easily grasp numbers so immense, so the true scale always eludes us. The distances are not only horizontal, stretching across the disk, but also vertical. The Milky Way is about 1,000 light-years thick in its main disk, though its halo extends far farther, tens of thousands of light-years above and below the plane. Stars and clusters drift in this vertical dimension, orbiting through the disk in cycles that take millions of years. The halo itself, filled with dark matter and ancient globular clusters, is so extensive that it makes the visible disk seem like only the central part of something much larger. When we study the galaxy's distances, we also come face to face with the concept of time. Because light takes time to travel, when we observe distant parts of the galaxy, we are looking into the past. A star 20,000 light-years away is seen as it was 20,000 years ago. If something dramatic were to happen to that star, we would not know until its light finally reached us. This means that the galaxy we observe is not the galaxy as it exists right now, but rather a tapestry woven of moments stretched across tens of thousands of years. Every glance into the night sky is a journey backward in time, each star a messenger from a different chapter of history. The immense distances also mean that stars and planets live their entire lives in relative isolation. While galaxies as a whole may collide and merge, within them, the distances between stars are so great that direct collisions are exceedingly rare. When galaxies interact, their stars pass by one another without touching, like grains of sand blowing through a storm. Gravity reshapes their paths, but the individual suns remain separated by enormous spaces. This vastness is both humbling and comforting, a reminder of the stability our solar system enjoys in its corner of the Milky Way. To grasp the distances in another way, consider the orbit of our Sun around the center of the galaxy. The sun moves at an average speed of about 500,000 miles per hour, a speed that is far beyond anything we can imagine experiencing. And yet, even at this blistering pace, it takes about 225 to 250 million years for the sun to complete a single orbit around the Milky Way center. That means the last time our solar system was in its current position, the Earth was in the age of the dinosaurs. In fact, the sun has only completed about 20 orbits since it was born. A reminder of just how immense the distances and timescales of the galaxy really are. As we move outward from our local perspective, we encounter even greater gulfs. Beyond the disk of the Milky Way lie its satellite galaxies, some hundreds of thousands of light years away. These companions, like the Large Magellanic Cloud and the Small Magellanic Cloud, are still part of our galactic neighborhood. Yet their distances remind us that even within a gravitationally bound family, the separations are staggering. Streams of stars stretch between these systems, torn away by tidal forces, forming bridges that span distances we can hardly imagine. And beyond even these satellites, we see other galaxies, millions of light years away, each as vast as or larger than our own. Compared to those intergalactic distances, the size of the Milky Way shrinks into something manageable, a single island in an ocean without shores. The scales keep expanding, from the distances between stars, to the width of the galaxy, to the gaps between galaxies, until the human mind can no longer follow. We are left with only a sense of smallness, and the quiet realization that the galaxy we call home is itself only a speck in a much grander universe. The Milky Way, with its 100,000 light-year span, is immense enough to stretch imagination to its limits. Yet, it is also delicate enough that we can trace its outlines in the night sky, watching the river of stars flow overhead. These distances, though impossible to traverse with our current technology, form the backdrop of our existence, shaping the context of our solar system and the rhythms of cosmic time. They remind us that while we live our lives on scales of years and miles, we are part of something that measures its life in millions of years and light years. When we ask where we are in the Milky Way, the answer is not just a set of coordinates or a dry astronomical fact. It is a story of perspective, a reminder that even in a galaxy with billions of stars, we occupy a particular and meaningful location. Our sun, with its family of planets, is not at the center of the galaxy, nor at the edge, but somewhere in between, nestled in one of the smaller spiral arms, quietly circling around the galactic core. This location, often taken for granted, has shaped not only the conditions of life on Earth, but also how we see the universe around us. To know our place is to begin to understand our relationship with the galaxy that cradles us. Our solar system resides in what is known as the Orion Arm, or more precisely, the Orion Spur. This is a minor arm, smaller and less prominent than the galaxy's major spiral arms, like the Perseus Arm or the Scutum Centaurus Arm. Picture the Milky Way as a great whirlpool of stars, and we are on one of the quieter streams, slightly off to the side, rather than in the thickest parts of the current. This arm, though modest in size, is home to many familiar sights in the night sky, including the bright constellations Orion and Cygnus, and it provides a stable environment in which our sun has thrived for billions of years. We are situated about 26,000 to 27,000 light years from the galactic center, placing us roughly halfway between the core and the outer edge of the galaxy's disk. This distance is not random, nor insignificant. Being closer to the center would place us in a region of greater chaos, where stars are more densely packed, where gravitational forces are stronger, and where the supermassive black hole at the heart of the Milky Way dominates the environment. In that crowded realm, close encounters between stars are more common, and radiation levels are higher, making it a less hospitable neighborhood for a fragile, life-bearing planet. Conversely, being too far toward the edge of the disk would mean living in a region with fewer heavy elements, fewer stellar nurseries, and fewer of the building blocks needed for complex chemistry. Our position, then, in this middle distance, is a kind of galactic Goldilocks zone, not too close, not too far, but just right for the emergence of planets and the possibility of life. The Sun itself orbits around the center of the Milky Way, carrying the Earth and all the other planets along with it. This orbit is not a perfect circle, but a long, slow path that takes hundreds of millions of years to complete. As we drift around the galaxy, we pass through different regions, encountering new spiral arms, interstellar clouds, and varying gravitational influences. Right now, we are in a relatively calm region of the Orion Arm, but millions of years from now, our descendants, if humanity still exists, may look up at a night sky filled with unfamiliar constellations. Shaped by the Sun's slow journey through the galaxy, this motion gives us another layer of perspective. We are not fixed points in the galaxy, but travelers. Every living creature that has ever walked on Earth, every tree that has ever grown, every drop of rain that has ever fallen, has been carried along on this immense galactic voyage. As the Earth orbits the Sun, and the Sun orbits the center of the Milky Way, we are participants in a cosmic dance that has been unfolding for billions of years. Our place in the galaxy is not just a location, but a trajectory, a path that ties us to the larger rhythms of the Milky Way. When we observe the night sky, we see the Milky Way stretching overhead as a river of stars. This is our view from inside the disk, looking outward along its plane. In one direction lies the dense, bright heart of the galaxy, obscured by thick clouds of interstellar dust, glowing faintly with the combined light of millions of stars. In the opposite direction, the stars thin out, leading toward the quieter outskirts. From our place in the Orion Arm, we are able to see both of these vistas, the crowded inner regions and the sparser outer ones. It gives us a privileged vantage point, a balanced view of the galaxy's structure. Our location also affects what we can study and discover. Because we are not buried deep in the galactic center, our view of the universe beyond the Milky Way is not completely blocked. The spaces between stars and dust clouds allow us windows through which we can see distant galaxies, nebulae, and cosmic events far beyond our own. If we were closer to the core, much of this view would be obscured, hidden behind dense walls of stars and dust. From our place, the universe opens up to us, offering glimpses of what lies beyond our galactic home. There is also a philosophical weight to knowing our place. In the grand scheme of the Milky Way, we are small, almost invisible. Our Sun is just one of perhaps 400 billion stars, and our solar system is an unremarkable one, not located in any prominent region, not marked by any cosmic landmarks. And yet, within this ordinary setting, extraordinary things have happened. Life arose on Earth. Consciousness emerged. Creatures like us developed the capacity to look outward, to wonder, to chart the galaxy, and to ask questions about our place in it. This paradox that we are both insignificant and profoundly significant gives our place in the galaxy a special meaning. Our position in the Orion Arm also connects us to other stars and systems. Nearby are stellar nurseries, where new stars are being born. The Orion Nebula, visible even with small telescopes, is a vast cloud of gas and dust where young stars are igniting. The Pleiades cluster, sometimes called the Seven Sisters, is another nearby feature, a group of young, hot stars that shine brightly in our skies. These neighbors remind us that our solar system is part of a larger family of stars, that we are not isolated but part of a community of suns moving together through space. As our Sun makes its orbit around the galaxy, it does not travel alone. It is accompanied by countless other stars, all of them circling the galactic center, their motions influenced by gravity and by the dark matter that pervades the Milky Way. Some stars move faster, some slower, some follow slightly different paths, but together they form the great rotation of the galaxy. Our place, then, not static, but part of a vast choreography, a motion so grand and slow that it takes hundreds of millions of years to see the pattern emerge. If we zoom out even farther, our place in the galaxy becomes part of yet another story. The Milky Way itself is part of the local group, a small cluster of galaxies dominated by the Milky Way and the Andromeda Galaxy. Within this cluster, our galaxy drifts through space, interacting with its neighbors, tugging at smaller satellite galaxies. and slowly moving toward Andromeda in a cosmic embrace that will one day reshape both galaxies. Our place in the Milky Way is, in this way, also our place in the larger universe, a position within layers upon layers of structures, each larger than the last. And yet, despite all this immensity, despite the overwhelming scales of distance and time, a particular place matters to us. It matters because it is the cradle of our story. It matters because from here, on a small planet orbiting a middle-aged star in an unremarkable arm of a vast galaxy, beings like us have learned to measure, to dream, and to tell stories about the cosmos. Our place in the galaxy is not marked by grandeur, but by perspective, by the ability to look outward and inward, to know both our smallness and our significance in the same breath. When we talk about the Milky Way, it is natural to think of it as immense, overwhelming, even beyond comprehension. And in many ways, it is. Stretching 100,000 light-years across, containing hundreds of billions of stars, surrounded by a halo of dark matter that holds it all together, the Milky Way is truly vast. But in the grand catalogue of galaxies, ours is neither the largest nor the smallest, neither the brightest nor the dimmest, neither the most unusual or the most ordinary. To understand our galaxy fully, it is helpful to compare it to the countless other galaxies scattered across the universe, each with its own shape, size, and history. By doing so, we gain perspective on what makes the Milky Way unique, and what makes it part of a much larger family of cosmic structures. Astronomers classify galaxies into several types. Spiral galaxies, like our Milky Way, are among the most beautiful, with sweeping arms of stars and gas curving outward from a central bulge. Elliptical galaxies, by contrast, are shaped more like spheres or ovals, with stars distributed smoothly throughout, lacking the graceful arms of spirals. Irregular galaxies, as the name suggests, have no defined shape at all, appearing as scattered clumps of stars and gas, often distorted by interactions with larger neighbors. The Milky Way, as a barred spiral, belongs to one of the most common and most striking categories. Yet it also has traits that distinguish it from others in its class. One of the closest points of comparison for the Milky Way is our neighbor, the Andromeda Galaxy. Andromeda, also a barred spiral, is larger than the Milky Way, spanning about 220,000 light-years across more than twice the size of our own galaxy. It is also estimated to contain 1 trillion stars, compared to the roughly 400 billion in the Milky Way. When we look at Andromeda in the night sky, it appears as a faint smudge of light, but in reality it is a giant, dwarfing the Milky Way in both size and stellar population. The two galaxies are gravitationally bound and moving slowly toward one another, destined to merge in about 4 to 5 billion years. When that collision occurs, the Milky Way and Andromeda will blend into a single, even larger elliptical galaxy, forever altering their structures and identities. The comparison with Andromeda reminds us that the Milky Way, while large, is not the biggest galaxy in the universe. Far larger still are giant elliptical galaxies, like the one at the center of the Virgo cluster, known as M87. This galaxy is a behemoth, spanning nearly 500,000 light-years and containing several trillion stars. At its heart lies a supermassive black hole billions of times more massive than our Sun, powerful enough that we have imaged its shadow with the Event Horizon Telescope. Compared to M87, the Milky Way is modest, a mid-sized galaxy among giants, and yet, while some galaxies are far larger, there are also many that are smaller. Dwarf galaxies, with only a few million or a few billion stars, are far more common than massive spirals or ellipticals. Some are so small that they barely qualify as galaxies at all, their stars scattered loosely and vulnerable to being stripped away by larger neighbors. The Milky Way itself is surrounded by such dwarfs, including the large and small Magellanic Clouds, which orbit our galaxy-like companions. These smaller systems remind us that the Milky Way, for all its grandeur, is just one scale of galactic existence, a middle ground between giants and dwarfs. Beyond differences in size, Galaxies also vary in their levels of activity. Some, like the Milky Way, are relatively calm, with steady but moderate rates of star formation. Others, called starburst galaxies, are much more active, producing new stars at furious rates, fueled by collisions or interactions with neighbors. Still others are quiescent, their star formation long since ceased, leaving only aging stellar populations glowing faintly in the dark. The Milky Way's star formation rate, producing a few new stars each year, places it in a balanced position, not dormant, but not extreme. It is, once again, a galaxy in the middle dot in terms of structure. The Milky Way's barred spiral form is shared by many galaxies, but not all spirals have the same features. Some have tightly wound arms, while others are more loosely curved. Some have strong, prominent bars, while others have none. The bar in the Milky Way is significant enough to shape its overall structure, channeling gas toward the center and influencing the formation of new stars. This bar, while not unique, gives the Milky Way a distinctive identity within the broad category of spirals. Comparisons also reveal that our galaxy's environment shapes its behavior. The Milky Way belongs to a small group of galaxies known as the Local Group, which contains about 80 members. Within this group, the Milky Way and Andromeda dominate, with the Triangulum Galaxy as a smaller but still significant member. Other galaxies in the group are dwarfs, many of which orbit the larger ones. This environment provides a relatively quiet neighborhood compared to larger clusters, where galaxies exist in the hundreds or thousands, packed closely together and subject to constant gravitational encounters. In that sense, the Milky Way lives in a suburb rather than a bustling city of galaxies, shielded from the constant turmoil of denser clusters. If we expand our comparison even further, we find that the Milky Way is also part of the Laniakea supercluster, an enormous structure containing hundreds of thousands of galaxies, stretching across 500 million light-years of space. Within this vast web, the Milky Way is but a single node, connected by filaments of galaxies and dark matter to countless others. When we look at maps of these superclusters, the Milky Way appears as just one dot among many, reminding us again of both its significance to us and its relative smallness in the cosmos. Comparisons with other galaxies also highlight the diversity of galactic histories. Some galaxies show evidence of violent mergers, their structures warped and twisted, their arms distorted into streams and tails. Others are remarkably undisturbed, holding their shapes for billions of years. The Milky Way bears the marks of both. It has consumed many smaller galaxies over time, their stars now mingling in its halo and disk. Yet it has also maintained its spiral form, continuing to grow steadily. It is neither the most violent nor the most peaceful of galaxies, but one whose story combines both quiet accumulation and dramatic encounters. Perhaps the most profound comparison we can make is not in size or structure, but in meaning. To us, the Milky Way is our home, the galaxy that holds our sun, our Earth, our history, and our future. But to someone living in another galaxy, if life exists elsewhere, our Milky Way might be just another faint smudge of light in their night sky, just as Andromeda appears to us. What is central to us is peripheral to them. This realization puts our galaxy in perspective, reminding us that the universe is not centered on us or on the Milky Way, but is a vast, interconnected web of countless galaxies, each with its own story, each with its own wonders. The act of comparing the Milky Way to other galaxies is not about diminishing its importance, but about situating it in the broader cosmos. It shows us that while our galaxy is remarkable, it is also typical, one of billions of spirals scattered throughout the observable universe. Its size, its structure, its history, these are shared by many others. Yet for us, it will always be unique, because it is where we belong, where our story unfolds, where life as we know it has taken root. As we have drifted together through the vast corridors of the Milky Way, we have traced its beginnings, wandered through its spiral arms, paused at its crowded core, and stretched our imaginations across distances that surpass anything our senses can measure. We have stepped back to see the structure of the galaxy, and then looked outward to understand our place within it. We have compared it to other galaxies, larger and smaller, quieter and more turbulent, each one a reminder that the universe is both endlessly diverse and bound by shared patterns. The Milky Way, for all its enormity, is not a cold, abstract thing. It is our home. It is the stage upon which the drama of stars and planets unfolds, the cradle where life has emerged, the framework in which our own sun and earth exist. Every breath we take, every heartbeat, every moment of human history has been carried along within this galaxy, orbiting the galactic center in a journey that will last hundreds of millions of years. To contemplate the Milky Way is to feel both small and deeply connected. Small, because we are but one species on one planet around one star among hundreds of billions. Connected, because the atoms in our bodies were forged in ancient stars, scattered into space by supernova, gathered into the clouds that formed our solar system, and shaped by the slow rhythms of the galaxy itself. We are not separate from the Milky Way. We are part of it, woven from its matter, carried along by its gravity, and illuminated by its stars. In comparing our galaxy to others, we are reminded that the Milky Way is just one among billions, a single swirl of light in a universe filled with them. Yet to us, it holds a special meaning, because it is here that we live, here that we look outward, and here that we wonder. The galaxy does not exist for us, but within it, we have found a home, a place where questions arise, where stories are told, and where meaning is made. As you let your thoughts settle and drift, imagine the Milky Way arching overhead, a great river of stars flowing through the night. Imagine its spiral arms turning slowly over millions of years, its stars being born and dying, its planets circling faithfully, its clusters wandering in the halo, its satellites tugging gently at its edges. Imagine the dark matter holding it all together, unseen but present, silent but essential. Imagine yourself within it, not separate, not outside, but a part of this grand, luminous whole. And let the immensity of it soothe you. The galaxy is vast enough to carry your thoughts far beyond the boundaries of daily life, vast enough to dissolve worry into perspective, vast enough to remind you that you are part of something enduring and beautiful. In the stillness of the night, with the Milky Way stretched across the sky, you are both small and infinite, both fleeting and eternal, both a single breath, and part of a cosmic story that has been unfolding for billions of years.